in today's class we are going to discuss about the equations having non-real roots as well as something about the non-real numbers. See, in our earlier classes we learnt about different types of number systems starting from the natural numbers to the real numbers, right? Natural numbers, whole numbers. Yeah, what you learnt in our previous classes about different types of number systems: natural numbers, whole numbers, integers, rationals along with irrationals, and the combination of these two, the union of these rationals and irrationals together is nothing but reals. All these systems you learnt in our previous classes, right? So most probably I think so in your 10th standard you learnt about these real numbers, and now in your plus 1 and plus 2 you need to utilize along with these number systems one more system, and we call that as complex number system. What we call it as complex numbers. That's what you need to learn your plus 1 and plus 2, right? So we have a separate chapter in your plus 1 and plus 2 related to these complex numbers, right? And now I am going to introduce what is a complex number and how they are formed, and what is the need to learn the complex numbers to solve different problems related to the quadratic expressions and equations. That's what I am going to deal in today's class, right? See, our human life requires different types of numbers in different situations. Okay, in some situations we need fractions, whereas in some situations we need integers also, and in some other situation we need to count the objects, counting numbers like that. So to fulfill the human requirements as well as to simplify our day-to-day activities, mathematics is continuously developing different types of number system. As a part of that extensions, as a part of the development, see, we developed natural numbers to whole numbers, we developed integers from the whole numbers, and then we developed rationals from their reals as per the requirements, right? And now we are going to solve something about the complex numbers. See, think about what is a complex number. And your second equation on the board, it is x square plus 4 is equals to 0. We need to find the roots for this. See, to find the roots we have different methods. We have factorization method, perfect square method, and formula method like that. First of all, if you think this is x square minus 4 is equals to 0, and if you factorize this x square minus 4, it becomes like x minus 2 into x plus 2 is equals to 0. Is it right? X minus 2 into x plus 2 is equals to 0. See, whenever the product becomes 0, the product becomes 0 when either this one or that one is 0. That means either x minus 2 is equals to 0 or x plus 2 is equals to 0. From there, your value of x is 2 or minus 2. Right? That's what we learned from the factorization method. There is another way to solve this. As I told you, if you have this x square minus 4 is equals to 0, on this type of factorization you have that x is equals to 2 or minus 2. In another way, what I am going to tell you is, in another way, if x square minus 4 is equals to 0 and this is x square is equals to 4, right? And you may write it like x is equals to plus or minus root 4 and that is equals to plus or minus 2. Then your values for the x are either plus 2 or minus 2. But what you say about the values of x for the equation x square plus 4 is equals to 0, right? In such a manner, if you wish to solve, since it is x square plus 4 is equals to 0, you may write it like x square is equals to minus 4, right? See, look here, like x square is equals to 4, we have here x square is equals to minus 4. If x square is equals to minus 4, what you say about the values of x? If x square is equals to minus 4, then x value is plus or minus square root of minus 4. Is it clear? If x square is equals to minus 4, then the values of x are plus or minus root of minus 4. Right? This is very clear. But to move for the next step, what you say about the value of root of minus 4? See, we don't know the square roots for the negative numbers. We have square roots for the positive numbers. Then from that idea, root 4 is 2. Then your values are plus or minus 2. But what you say about the square root of the negative numbers? See, you just think it. See, x square is equals to minus 4 in the sense we need to multiply x with x to make a negative number. See, we are multiplying a number with itself to make a negative number. See, if you think about x, if that x is positive, we are multiplying that number with itself. That means positive into positive, can't be negative. So x is not positive. And if you if x is negative, if suppose x is negative, x square means x into x. That means negative into negative. Again it is positive. See, look here. See, I don't know about x. I am trying to find the value of x. If I suppose my x as positive, x square is still positive, but it is given as negative. If suppose my x is negative, x square is then positive, but it is given as negative. So x is not positive, x is not negative. So neither positive nor negative number is the only number which is 0, but if you replace x with 0, still it fails to find the result as minus 4. That in the sense, it is very clear that if x square is equals to minus 4, x has no real values. X has no real values. There is no real value for x. So x has no real values. But then what you say about that x? Is there any possibility of x? Right. Then at this position, there arises the concept of imaginary numbers. See, real numbers, the name itself is suggesting they are the real. They are existing. But what you say about the imaginary numbers? See, if a value is not possible in reals, if a value is not existing in reals, then the mathematicians, then the people with the logic thinks that we don't know whether the result is there or not. Then in such a case, they think that if it is, that in the sense they are imagining. Okay, that's why at this case the new concept arises and we call that is about the imaginary numbers. Right? Once again, look this. I am going to give you the definition of the imaginary number and the utilization, how that system develops. Right? See, for x square is equals to minus 4, we have this way of simplification to get the value of x. For these type of equations, if x square plus 4 is equals to 0, then x is plus or minus root minus 4. Up to this it is okay. But you don't have a chance to simplify this root of minus 4. Why? Square root of a negative number not possible. Square root of a negative number is not exist in real numbers. So it is not real. So exactly x has no real values. That means this equation has no real roots. Think it. This equation has no roots is different from no real roots, right? No real roots. This equation has no real roots. So if it has roots outside of the real, then how the roots will be? Okay, at this position, okay, there is a need to extend real numbers. There is a need to develop a new number system, but we don't know whether those numbers exist or not. Since we don't know about the existence of those numbers, we call those numbers as imaginary numbers, right? So what I am going to tell you is root 4 value is 2. Is it clear? But what you say about root of minus 4? Yeah, we don't know about the root of minus 4. Since we don't know about this root of minus 4, I will rewrite this root of minus 4 as this, like this. Root of minus 1 into 4. Is it clear? Under the root, minus 4 can be written as root of minus 1 into 4. And it can be written as root of minus 1 into root of 4. Is it clear? Absolutely. And this is equals to, we don't have the value of root of minus 1, but we have the value of root 4 as 2. That means this unknown value with 2 you need to multiply. So like this, if you have a negative number under the square root, you have a chance to simplify like that. Then all this together will suggest us the importance of the new number system, but we don't know about the existence of those numbers, and that's why we call those numbers as imaginary numbers. They are imagining, they are expecting that suppose there is a value for root of minus 1. We don't know the value of root of minus 1. If there is a value for root of minus 1, you just that value as I. And this I is read as iota. It's a Greek letter actually, right? Greek alphabet, okay? So if root of minus 1 is equals to I, then what you say about the root of minus 4? Then root of minus 4 can be written as root of minus 1 into root 4. Is it right? So root of minus 1, this bracket unknown value is I into 2. It becomes like 2I. And for suppose if you know that root of minus 1 is I, then with that supposition, we have a chance to represent, to find the square root values like this 2i. So what is the square root of minus 4? Square root of minus 4 is 2i. But this is not a real number. This is an imaginary number. Is really exist those imaginary numbers? We don't see. There is no real existence of those numbers. They are just imaginary numbers. We are imagining that they are the numbers. With that imagination, again different aspects of mathematics get simplified. Okay, so this imagination is also an important task in understanding different theories existing in this universe. That's why we are following with such a theory, right? Once again I am repeating you, square root of a positive number is real, but square root of a negative number is not real, right? So is there any value for the square root of a negative number? See, that thought process developed an imaginary system, right? So those imaginary numbers are this. Root of minus 1 is the imaginary quantity. This is the fundamental item of those imaginary numbers. Root of minus 1 is equals to I is the imaginary quantity, and we call it as imaginary quantity or the imaginary number. Then if you look at the complete system of those imaginary numbers, all the numbers of the format some ai such that a belongs to R are the imaginary numbers. For suppose I, 2i, minus 3i, 4 by 17i, 0 into I. Okay, so most probably 0 into I is not very imaginary because you may say it as 0. Right, I, 2i, minus 3i, 4 by 17i, etc. All these things. You need to multiply an imaginary number with a real number. That product, all these type of products are mentioned as the imaginary numbers, right? How many real numbers you have? You have uncountable number of real numbers in the real number system, and if you multiply all those uncountable number of real numbers with the imaginary quantity I, then there arises another new system. Again it contains an uncountable number of elements which are of this format, and all those numbers together is mentioned as imaginary numbers, right? Have a look at this. At the end, I is equals to root of minus 1. You need to memorize that the value of I, imaginary quantity, is root of minus 1. Everywhere if you find a negative number under the square root, then in that position, that root of that minus 1 is I, you need to utilize. And another thing what I told you is, see, since these are the imaginary numbers, since this is all about the imagination, then in that imagination, there is no matter of comparison. See, you don't say which is positive, which is great, which is negative, which is greater, which is lesser in the imaginary quantities. See, I is less than 2i. This is 1i, this is 2i. But see, you may like to say that 1i is less than 2i. It is wrong analysis of this because I is imaginary. You don't know about that I, then how can you say that 1i is less than 2i? This is just a representation, and here the comparison is completely not allowed in imaginary numbers, right? At the end, at this contest, again you face all these situations, different types of problems related to this in the chapter called the complex numbers. But see, to solve different types of equations in this quadratic, sometimes you may find the roots which are not real. See, if the roots are not real, then automatically the roots will be imaginary. Then in that case, to identify the roots, we need the concept related to this imaginary quantity, right? At the end, what I told you, see, I am again concluding you that you need to accept what is that I. I is usually read as iota or it's a Greek letter, and that I value is indicated by I is equals to root of minus 1, right? What you say about I? Root of minus 1. See, what you say about I square, since I is root of minus 1, then automatically I square is minus 1 because multiplication of root of minus 1 with root of minus 1. Is it clear? Yeah. What you say about I cube? Again, since this is I square, if you multiply both sides with I, it becomes like I cube is equals to minus I. And since I cube is minus I, again if you multiply with I, what will happen? I power 4. See, think in different ways. Multiplication with I on both sides, or squaring this I square on both sides. See, I square whole square is I power 4, and this side minus 1 whole square is 1. Look this, I is root of minus 1, I square is minus 1, I cube is minus I power 4 is equals to 1. So you need to observe all these things, but you need to memorize this I is equals to root of minus 1. No need to memorize all these values, right? You need to memorize the first one, but you need to identify everything, right? If I power 4 is equals to 1, then what you say about I power 5? See, I power 4 is equals to 1, right? Again, you need to multiply with I on both sides, then I power 5 is equals to I. See, I power 4 is equals to I, then what you say about I power 6? See, I power 6 means, again multiplication with I on both sides. Then I power 6 will become I square. But what you say about I square? Minus 1. Look, a pattern is following here. Then what you say about I power 7? Again we need to multiply with I. This is I power 7. And if you multiply here, it becomes minus I. And again if you multiply, I power 8 is equals to 1. If you look this, see, 1 minus 1. Yeah, not 1 actually. The first one is I, right? Yeah, with this, I, yeah, minus 1, minus I, 1. I minus 1, minus I, 1. I minus 1, minus I, 1. Like that, this is an oscillating sequence. For every 4 numbers, the powers of y will run. If you observe all these things, I power 4 is equals to 1, I power 8 is equals to 1. If you move like that, everywhere I power a 4 multiple is always 1. I power a 4 multiple, 4 power something is always 1. Okay, that is the sense. See, I power 4 multiple means how can you find this I power 4 multiple? You may write it like I power 4 power k. Since I power 4 is 1, 1 power k, and that is equals to 1. Is it right? So that indicates that I power 4 is 1, I power 8 is 1, I power 12 is 1. Yeah, like that I power 16, I power 20, I power 100, everything is 1 if the power is a 4 multiple and the base is an I. Right? Keep in mind, you see, sometimes they may ask you to find values of like this. What you say about I power 2020? Just think a while, we are thinking about I power 2020. Whether this 2020 is a 4 multiple or not, that's what you need to check. See, what is the checking for the 4 multiples? You need to look at the last 2 digits of the number. See, the last 2 digits is 20, so a 4 multiple. So this 2020 is a 4 multiple. So I power 4 multiple. Again, this is 1. So the value of I power 2020 is again 1. Right? So, see, at the end, what we need is, we need the roots for the quadratic expressions, but to simplify all those things, we need a preliminary knowledge related to this part. Imaginary quantity, right? I am erasing everything, just go with a screenshot. Right. And now, if you face different equations, then it is a chance for you to represent, what? Imaginary quantities. For example, x square minus 1 is equals to 0. Then your values of x are plus or minus 1. And if you say x square plus 1 is equals to 0. Since x square plus 1 is equals to 0, x square is equals to minus 1 and x is equals to plus or minus of root minus 1, think why x is equals to plus or minus I. Is it right or not? You need to check. How can you check? At the end, my values of x are, what we have? I or minus I. Replace x with I or with minus I. If you replace with I square plus 1 is clearly 0. If you replace x with minus I, again minus I whole square plus 1 is again a 0. So either of these two is a root for this x square plus 1 is equals to 0. And if you think, for suppose if I have x square plus 4 is equals to 0, then the roots of x are directly given as plus or minus 2i. Try to check if you need. What you say about x square? Something like if I say plus 10 is equals to 0. Think a while. What you say about the roots of x square plus 10 is equals to 0. Don't know the value of root 10, so but I will write it like this. X square is equals to minus 10. Right. And then x square is equals to minus 10. At the next step you can write it like this. X is equals to plus or minus root of minus 10. See, uh, pay your attention at these two steps, right? X square is equals to minus 10. This is some quantity, right? So squaring when moves that side will become plus or minus of the root. So x is equals to plus or minus root of minus 10. And then x is equals to plus or minus under the root what we have? Minus 1 along with root 10. Right? How can we write this minus 10? Minus 1 into 10. And that root of minus 1 is I, and the root of 10 will remain like this, and then x is equals to plus or minus root 10I, right? See, so at the end, using these imaginary quantities, we can find the roots for these type of equations, right? Have a look at this, and I will give you few more problems related to the imaginary quantity. Complex numbers are of the format sum a plus ib such that a comma b belongs to the reals and I is equals to root of minus 1. This is the basic definition for the format of complex numbers. I think you know about the rational numbers, right? In your earlier classes you learnt about the rationals. See, the rational numbers are of the format p by q. Do you know it? Yeah, such a definition for the complex. This is the definition of complex. See, this is just like the definition of rationals. So the rational numbers are usually of the format p by q such that p comma q belongs to the integers and q not equals to 0. See, think a while about this rational system. See, all these numbers are rationals, but here all these numbers are the complex numbers. Look a while, you need to take two real numbers and you need to combine, right? See, what I have real numbers and I have imaginary numbers also. Yeah, we learnt about real numbers and we learnt about the imaginary numbers. See, the real numbers, what we have in the real numbers, we have positives, negatives, 0, fractions and everything in the real numbers, like 2, minus 3, 7 by 4, 0, minus root 10, all these things are comes under reals. See, I just mentioned you few. And about the imaginary, what you say? I, 7i, minus 8i, all this, see something like 3 by 4i, etc. All these numbers are under imaginary numbers. Now, see, you need to combine these real numbers along with the imaginary numbers, then the new system forms. Then the newly formed numbers are all collected and named as system of complex numbers. For suppose, say, take any real number, take any imaginary number. It becomes like this: 2 plus I, 3 minus 4i, 5 plus 0 into I, minus 7 plus 13 by 2i. See, it's a combination, right? Then all the numbers are of the form a plus ib. A is a real number and ib an imaginary number, right? And in depth, if you move, this a is called the real part of the complex number. This b is called the imaginary part of the complex number, right? At present, we don't need all those definitions, right? We need just the basic representation of the complex number. It is of the format a plus ib. If you look, if this b becomes 0, yeah, I gave an example here. If this b becomes 0, 0 into I is just 0 and 5 plus 0, if you simplify it is 5. See, this 5 is clearly real, but it is, you have a chance to represent that real number in the form of a plus ib. That means every real number is a complex number, right? So at the end, what I have another conclusion, that real numbers are the subset of the complex numbers. Every real number is a complex number, but every complex number need not be a real. At present, we need just the representation of the complex number to find the complex roots of the quadratic expressions or quadratic equations. Just have a look, and I will give you few examples related to the equations having these terms as the roots, right? Yeah, look at the board. We have three equations, and if you try to find the roots for those three equations, and the roots are actually not real, and that means you have the roots of these equations in the complex number system, right? So again, to solve these equations, either we need to move with the what? Factorization method, or with the formula method, or with the perfect square method. We have three ways to find the roots, right? So first of all, I am going to move with the factorization method. See, look at the equation. What is x square minus 4x plus 4 is equals to 0. Look this, I am going to find the roots. see, I am moving with the perfect square method, or you just move with the formula method, no problem, right? X square minus 4x is equals to minus 1. Is it clear? Yeah. I did a mistake actually. No problem. Try to solve it. X square minus 4x plus 4 is equals to 4 minus 1. See, x square minus 4x is equals to minus 1. I need to form what? I need to form a perfect square. To form that, I am adding 4 on both sides. Then this side it becomes like x minus 2 whole square, and that side it becomes like 3. Yeah, x minus 2 whole square is equals to 3, and then x minus 2 is equals to plus or minus root 3. Right. Since x minus 2 is equals to plus or minus 3, x is equals to 2 plus or minus 3. If you send to that side, then at the end this equation has two roots, and one root of it is 2 plus root 3, and the other root of it is 2 minus root 3. Right? Look at the roots, 2 plus root 3 and 2 minus root 3. See, both the roots are real only, they are not complex. Okay, see, this is my equation. I expected the roots may be in complex, but at the end what I observed that the roots are real only. There is no imaginary number, there is no negative value in the square root. If you have a negative number in the square root, then it comes under what? Imaginary quantity. Right? Just have a look at this. Yeah, how can you get a negative value under the square root? For suppose, yeah, instead of this I, if I gave you 7 like this, I am just rearranging the question. Look here. First suppose if x square minus 4x plus 7 is equals to 0, then what you say about the roots? Since it is plus 7, then what will happen? X square minus 4x is equals to minus 7. Then since we are adding 4 on both sides, and this is 4 minus 7, and at this side you have that minus 3, and since it is minus 3, then x minus 2 is equals to plus or minus root of minus 3. And you know that, see, this plus or minus root of minus 3 can be written as root of minus 1 is I, right? So 2 plus or minus I root 3. Then in that case, one root is 2 plus I root 3 and the other root is 2 minus I root 3. Yeah, just I changed that 1 to the 7. If this number is a 1, then the roots of the equation are real only, but they are irrational. One is 2 plus root 3 and the other one is 2 minus root 3 if it is 1. But to get a complex roots, I am just changing the equation, right? This is my class, no? So I can change the questions in any way, as per my requirement, as per my choice, right? But actually in the examinations or in the practice sheets, you will face an equation. See, you have no chance to change the equation actually. Then you just try to find the roots. Sometimes the roots may be real and sometimes the roots may be complex. And have a look for this equation. X square minus 4x plus 7 is equals to 0. We are going to find the roots of this equation by the perfect square method, right? And for that, first send this plus 7 that side, it becomes minus 7. And now to make a perfect square, I need to add 4 on both sides. Since by adding 4 on both sides, it's become like this. X minus 2 whole square is equals to minus 3. I need to find x. So if you apply square root on both sides, this is x minus 2 and there that side this is plus or minus root of minus 3. Under the root, since we have minus sign, that minus sign is nothing but an I. So I, and 3 is still in the root, I root 3. So send this to that side, then x becomes 2 plus I root 3 or 2 minus I root 3. So this is one such an equation having complex roots, right? So for this type of equation, we don't have real roots. Okay? How can you comment about the roots of this equation? The first thing, this equation has no real roots. And the other thing, this equation has two complex roots. And the third thing, the roots of this equation are 2 plus I root 3 and 2 minus root 3. These are three different comments related to the roots of this equation, right? If you find any one among the options, you can choose that one as your answer, the objective type of questions. Is it clear? I can move for the next question, right? So you just think about the next one. I am arranging this to solve the next one. Right. Right. What you say about that x square plus 64 is equals to 0? You need to solve that x square plus 64 is equals to 0. Yeah. See, no need to go with the perfect square method. Directly it is the perfect square. X square is clearly a perfect square, right? Then no need to utilize factorization method or the formula method. See, directly we have a chance to write that x square is equals to minus 64. Since x square is equals to minus 64, x can be written as plus or minus root of minus 64. This minus 64 is a quantity. So if you send square that side, you need to get a root for that minus 64. But as in squaring, plus and minus both will become positive, right? You have a chance to write like this. So x is equals to plus or minus root minus 64. And x is equals to plus or minus root of minus 64 can be written as minus 1 into 64, and that is equals to plus or minus root of minus 1 is I and root of 64 is 8, and this is plus or minus 8i. So at the end there are two possibilities, one is 8i and the other is minus 8i. So both 8i and minus 8i are the roots for this x square plus 64 is equals to 0. Is it clear? See. So this is the way to find the roots for these type of equations. And next I have another equation. You need to find roots for that. See, again I told you we have different chances to find the roots, right? For this equation also, excuse me. Right, excuse me. Yeah, this equation, if you look, the coefficient of x square is real number. The coefficient of x is imaginary, right? Then in that case also, the situation is somewhat tricky and difficult, but still you have three options to find the roots: formula method, factorization method, and as well as perfect square method. Those three methods are again applicable for this to solve. But if you have equations of this format, better if you move with the formula method, right? Instead of wasting time with the factorization or perfect square method, it is better if you move with the formula method. And now I am going to find the roots for this x square minus 3ix plus 2 is equals to 0. So to find the roots, what I am going to do? First of all, you need to compare this equation with the general quadratic equation, and that ax square plus bx plus c is equals to 0. If you compare, your value of a is 1 and your value of b, which is the x coefficient. Here b is the x coefficient, and the given equation x coefficient is minus 3i, and the constant term c is equals to 2. I have all these three things. Then I need to find the roots for this equation. And the formula to find the roots is minus b plus or minus square root of b square minus 4ac divided by 2a. You need to substitute all those values and to simplify. See, b is minus 3i. What is minus b? 3i. Plus or minus square root of b square. See, b is minus 3i. You need to square that one, okay? If you think, see, minus 3i. We are squaring. Minus square is positive, is 9. I square is minus 1. And at the end, minus b square is minus 9. Is it right? Once again, think about it. Minus a square is plus. 3 square is 9. I square is minus 1. So minus 9. And then minus 4 into, yeah, a is what? 1 into, and c is what? 2. Divided by 2 into x square coefficient is 1. And that is equals to 3i plus or minus minus 9 minus 8 is just nothing but root of minus 17. 4 2 is 8 9. So divided by 2. And this minus root 17 can be written as root of minus 1 is I, and that is root 17. So that is equals to 3i plus or minus root 17i by 2. At the end, what you need to say? See, you don't have a chance to add 3 and root 17. Yeah, it can be written as 3 plus root 17i by 2 or 3 minus root 17i by 2. Okay, have a look at this. These are the roots for this equation. See, you may get these roots by using perfect square method also, but it involves with I square theorem. You may get the roots by using factorization method also, but it is maybe, see, it takes very time consuming, okay? But if you go with the formula, it is easy to find the roots. And at the end, what I am going to conclude you is, this is a quadratic equation, but whose roots are not reals, the roots are complex numbers. Have a look at this. Look at the problem on the board. X square plus ix plus 6 is equals to 0. Try to find the roots for this using formula method, right? See, as per the comparison, our value of a is equals to 1 and the value of b is equals to I and the value of c is equals to 6. Since we are going to find the roots for this equation, then our roots is equals to what? Minus b plus or minus root of b square minus 4ac by 2a, and that is equals to minus b. B is I, right? Then what you say about minus b? Minus I plus or minus root of b square. See, b is I and b square is minus 1. Okay? Minus 4 times a is 1. And what you say about 6? C is 6. Is it right? Yeah. And then what we have? See, 6 fours is 24 and minus 1. Minus 25 and divided by 2 into 1 is there. And this is equals to minus I plus or minus square root of minus 25 divided by 2. And under the square root what we have? Minus 25. It can be written as 5i. So this is equals to minus I plus or minus 5i divided by 2. You have two options. Minus I plus 5i by 2 minus I minus 5i by 2. And if you simplify this, this is 2i. And if you simplify this is minus 3i. So at the end, your roots for the equation are 2i and minus 3i. If you wish to cross check whether it is right or wrong, you just go with sum of the roots and product of the roots again. See, the sum of the roots is what? 2i and minus 3i. Sum of the roots is minus i. If you apply sum of the roots formula like minus b by a here, again it is minus i. Likewise, you have a chance to check the product of the roots also. And at the end, this is the way to find the roots for this equation. Have a look at this.